So welcome student for today's class on enzyme classification. So this is our lecture today, enzyme classification. So enzyme classifications is basically divided into the 6 classes. So we have 6 classes. Oxidoreductase is here. First class is oxidoreductase, second is a transferase, third is a hydrolase, fourth is a lyase, fifth is a isomerase, and sixth is a ligase. So based on these 6 classes, we have enzyme classification, and how these names have been given are based on the reaction type of reaction they catalyze, right? So which type of reaction they catalyze, based on them we have 6 different classes of enzyme classification. So enzyme classification. So first one is a oxidoreductase. So what is happening here? Oxidoreductase. Here we have, suppose this is a oxidation and reduction reaction. So basically this is oxidation reaction, reduction reaction. So this is AH2. So we have A group and B group here, and with the first group we have 2 hydrogen attached here. So when we say oxidation reduction reaction, it is basically transfer of electron, hydroxyl group or the hydrogen ion. So we have hydrogen group here, and this hydrogen group are transferred from A to the B. So we have A on the right side and BH2. So this hydrogen groups has transferred to B. So that is why we say A has got oxidized and B has got reduced. So oxidoreductase reaction is generally coupled reaction. Oxidation and reduction both are coupled. So we have this reaction. So this is an oxidoreductase reaction. And which are the examples? Enzyme alcohol dehydrogenase, cytochrome oxidase. So these two are the example of the oxidoreductase reaction. Next reaction is a transfer reaction. So transferase. So transferase is a group transfer reaction. So again we have here A and B, and here A is attached with one group, X group. So X is any group, and this group can transfer to B. So A plus BX. So that is the group transfer reaction. So that is a group transfer. So X group from A has transferred to the B here. So we got A plus BX. Okay. So next we have example of it. So hexokinase, for example, phosphorus group transfer, or transaminase, amino group transfer. So likewise we have hexokinase and transaminase are the enzyme which are example of this transferase group. Next example classification we have is a hydrolase. Hydrolase is a hydrolysis reaction. So everybody is familiar with hydrolysis. Hydrolysis means there is a water involved. Is there water involved? Yes, it is water involved. H2O is a water involved. And which bonds are there? A and B are bonded together. Now with the presence of the water, what happens? These two bonds can break and we get here AH and BOH. So each group get attached with the hydrogen atom. So transfer of functional group to the water molecule. So one group goes to the water H and other group B goes to the OH of the water. So that is a hydrolysis reaction. Example of it is lipase, and the urease are the example of hydrolysis reaction. Next we have is a lyase. So what is lyase? Lyase is basically addition or elimination reaction. So addition of group to the double bond or formation of double bond by the removal of group. So lyases, whenever we have lyases, we can get the double bond formation, or we are adding the group to the double bond. So that is a lyase reaction. Okay. So lyases A and B are joined together, and we have X and Y joined together, and here we are getting AX and BY. So here, so these two groups, this X and Y can attach to AB here. Okay, so that is the addition of the group to the double bond. Example is aldolase and fumarase. Next class is a isomerase. So what is isomerase? Isomers, we know isomers. There are different type of isomer chemistry or the biochemistry. So here we have interconversion of isomer is catalyzed by isomerase. So here we have A and we have A prime. So here A is getting converted to A prime, and this is a transfer of group within the molecule to form the isomeric compound. So within the molecule, the groups get rearranged and we get the isomer formation. So here is a isomer formation A to A prime, and the example is a triose phosphate isomerase and the phosphohexose isomerase. So these are the example of the isomerase. Next is a ligase molecule. So ligase molecules, here is a condensation reaction. A plus B we have. Now we want to condense this molecule, we want to join two molecule. So when we say we want to join two molecule A and B together, there may be the carbon-carbon bond formation, or carbon-sulfur bond formation, carbon-nitrogen bond formation, or carbon-oxygen bond formation, and this bond formation happens by the condensation reaction. So this is a condensation reaction in which the requirement of ATP is there. So with the presence of the ATP, it reaction get catalyzed and ATP get converted into the ADP plus inorganic phosphate. So this is ATP requiring reaction. So here ATP is required most of time. An example of ligase is glutamine synthetase and acetyl-CoA carboxylase. So glutamine synthetase and the acetyl-CoA carboxylase are the example of these ligases. So basically we have seen the type of the reaction. So oxidoreductase reaction is there, transferases reaction is there, hydrolysis reaction is there, lyases reaction is there, isomerases are there, and ligases are there. So these are the different kinds of reactions. So major 6 kind of reaction which are occurring in the biological system, and all our enzymes can be classified based on these 6 major classes. So these are the 6 major classes of the enzyme: oxidoreductases, transferases, hydrolyses, lyases, isomerases, and ligases. So you should remember these 6 classes of the enzyme. So when we say enzyme, for example, we say hexokinase. So hexokinase, most of enzyme we write as a ase. Okay, sucrase. So that is ase is a suffix we attach with the enzyme, but that is a common nomenclature. Usually what happens that people they will say, some people will say hexokinase, other person they will say okay that is this enzyme. So they will give different name to the same enzyme. So many people in the world are researching on the different enzyme and they will give different name to same molecule. So what happens, it created the confusion among the scientific community, and they want to know that one thing is there, it should be recognized by one thing only. Or sometimes there is a trypsin enzyme. Trypsin means based on tri and its property to tear down, we give name trypsin. So people have their own logic and they will give name to this one enzymes. To avoid the confusion and to give the same name to the same enzyme, the IUB, this International Union in Biochemistry, they decided okay, we will get away with this one and we will have the standard enzyme name. For that one, they created the enzyme classification. So enzyme classification number, for example, this is an enzyme classification number EC 1.1.1.1. So one example I have shown with this one. So what does it stands for? For example, we have hexokinase, very familiar enzyme to us. So this is hexokinase and this is a enzyme classification 2.7.1.1. So what is 2? It is a class name. So this is a transferase is a second our second class. So we have taken 2 here. What is 7? 7 is a subclass. That is a phosphotransferase. So that is a 7 here. Then O. So transfer is happening to something. Okay, so where transfer is happening, it is happening to OH group. So hexokinase, phosphorus transfer is happening to OH group. So we have given 1 here. 1 stand for, okay, OH is our acceptor group. We want to go in detail again. Now which acceptor? Now fourth one is a glucose as a phosphoryl group acceptor. So that is why we have given name enzyme commission 2.7.1.1. So that is, it means hexokinase, and it means that second is our class, subclass is a phosphotransferase. 1 stands for OH acceptor, again 1 stands for glucose as a phosphoryl group acceptor. So these are the enzyme classification numbers. So coming to our point, so here at least easily you can demarcate which major group enzyme belongs. So one group oxidoreductase. So first letter you see subclass 1, 2 transferase, 3 hydrolysis, here 4 lyases, here 5 isomerases, 6 ligases. And if you want to go in detail and if you want to break down the name, you can go in detail like this: class, subclass, then which is acceptor, which is again main acceptor. So based on this we can classify the enzyme. So that is basically enzyme classification number. So enzyme classification is very important. So whenever any biochemical reaction we are catalyzing, for example glucose to glucose 6 phosphate, and there is a enzyme hexokinase is involved. Hexokinase means some phosphoryl group transfer reaction is there. So we know that okay, this is a phosphoryl group transfer reaction, let's put ATP here. So we put ATP, that way we can get the phosphate group involvement in that one. So that way that reaction belongs to the transferase reaction. So basically if you analyze any biochemical reaction, you can know that which group this reaction belong, either of 6 groups. So enzyme classification is very important topic in our syllabus. So that's all about enzyme classification. Thank you for today's lecture.